So there are two aspects to the software part of the Autotuner. One is the Android phone app and other one is the Raspberry Pi. Android phone app, I found pure data library which deals with the musicals and analyzing the sound. So I just used the ready-made library that is available and added pitch detection algorithms specific to my needs, then the user interface, etc. Then I added also the web client on the Android phone to communicate with the web server that's running on Raspberry Pi. In addition to web server, there is an Autotuner process that's running on Raspberry Pi, which does a lot of things, including it stores the database of notes and strings so that it knows which strings have which notes and what is the distance between those strings, etc. It also has code for doing the calibration of motors. It has the tuning algorithm, which is the heart of all of this project. It has timeout and safety knobs so that the program doesn't get stuck for forever doing the same thing. And of course, it has motor controls to make the project work. One of the key things that I spent a lot of time on was running these two separate processes and doing inter-process communication between them to pass messages back and forth. One of the main reasons for passing the messages back and forth is so that only when the Autotuner program is ready to tune, then only it will tell web server to accept the data and send it to the Autotuner process. All other times, even if the web server receives data from the Android phone app, it will just ignore it. That's another way I reduce the noise induced by spurious noise that's coming all over from the different places. So here is the application for Android that I wrote, which measures the pitch of the note that it hears. So currently, whatever I am talking, it's trying to interpret those notes. It shows the frequency in hertz, the note that would correspond to it, and the volume. Also, it has the parameters, optional setting to change the threshold of volume at which it detects the pitch. So here it's currently set to 70, but for better noise filtering we can set it to say 85 or 90 dB. That way the spurious sound will not be detected as the pitch from the music from Santoor. So here you can see no sound below 85 dB will be detected, and that's one of the ways to reduce the noise caused by spurious noise from other sources when tuning this instrument.